This video is going to go through how to prove some trig identities, but I've already done all the solutions, so I'm just going to go through them with you. The first one was proving that cos squared minus sine squared over cos squared plus sine times cos equals 1 minus tan theta. Well, the first thing I did was realize that tan theta was sine over cos. And these are all going to be formulas from your formula sheet. And then I chose that formula to use because I know I want sines and coses eventually. Then what I did is make common denominators. So 1 is the same as cos out of cos. And now I have two common denominators, so I get cos theta minus sine theta all over cos theta. And that's probably going to be as far as I can go on that right hand side. On the left hand side, cos squared minus sine squared theta. I'm not going to do anything with that yet, but on the bottom I've got cos squared and I've got a cos. Both of these pieces of this addition, I can factor out a cos. And when I do, cos squared divided by cos just leaves one cosine. And sine squared cos divided by cos just leaves sine. I've factored out cosine. Then I realized that on the top, I can do cosine squared minus sine squared. I can make that, it's just like difference of squares, like x squared minus y squared. I can do the same thing and do, this is the same as cos minus sine, cos plus sine. And then you see what I've done here, there's a slash through it because I knew I wanted to get this cos plus sine so I could cancel it out with the bottom. Because when I cancel out cos plus sine on top and cos plus sine on the bottom, I'm just left with cos minus sine over cos, which is my right hand side. And since my left side equals my right side, therefore I've proven 9a true. This is 9a right out of page 417. And here's 9b from the same page. I started with tan squared minus sine squared x, and I'm trying to prove that that equals sine squared x, tan squared x. Well, again, here I'm probably going to start with the right hand side, because I'm not sure what to do with the left hand side yet, but I know tan squared is just sine over cos, both squared because tan was squared. So tan squared is just sine squared over cos squared. So I have sine squared times sine squared, which is sine to the power 4 of x, all over cos squared. And now I'm done on the right hand side. Back to the left hand side. I'll use the same formula, tan squared. I know tan is sine over cos, so tan squared is just sine squared over cos squared. But now I want to do common denominators, so make this sine squared also out of cos squared by timesing top and bottom by cos squared. That gives me a common denominator of cos squared. And on top, I've got the product of two things, sine squared times cos. But I notice that there's a sine squared here and a sine squared here. I can factor out that sine squared. Pull a sine squared out in front of sine squared, divide, you get 1. Divide sine squared cos squared by sine squared, you just get cos squared. And that's good because I have sine squared out in front and in brackets 1 minus cos squared. Well, 1 minus cos squared is the same as sine squared. Now I have sine squared times sine squared over cos squared, which is just sine to the power 4 x all over cos squared. And since I have left side equals right side, therefore I've proven it true. That's 9b. Here's 9c from page 417. I started with tan squared x minus cos squared x, and I'm trying to prove that that equals 1 over cos squared x minus 1 minus cos squared x. It took me a couple minutes, maybe, or a few seconds, I'm not sure, when I was thinking about what to do with this one, but I knew I was going to need common denominator. I'm guessing that I started on the left thinking, well, same as the last two. I know tan squared is just sine squared over cos squared. And now let's do common denominator. To get this cos squared, also out of cos squared, I times the top and bottom by cos squared. When I do that, I get sine squared minus cos squared times cos squared, which is cos 4, all over the common denominator. And from there, I wouldn't have known where to go, because that's pretty much it. I don't have good rules for simplifying that. But I know that the right-hand side now, it would definitely be good to try and also get the denominator out of cos squared. So my first step on the right-hand side then was to say, okay, we've got 1 out of cos squared. Let's make this number also out of cos squared, times the top and the bottom by cos squared. So cos squared and cos squared, one on top of the other, just makes 1. And then this last cos squared times its top and its bottom by cos squared as well. When I do that, I can make one big common denominator, and I get 1 minus the cos squared minus cos squared times cos squared is cos 4. And that turns out to be perfect because 1 minus cos squared is just sine squared. So I end up with sine squared minus cos to the power of 4x all over cos squared, which is the left-hand side, which is perfect. Because since the left-hand side equals the right-hand side, I've proven that this is indeed true. Also on page 417, here's question 9d. It starts with 1 over 1 plus cos plus 1 over 1 minus cos, and on the right hand side I have 2 over sine squared theta. There wasn't a lot to do there. I looked at that and thought, I'll save it for a bit. I definitely need to do something with these denominators to get closer to sine squared. So what I did was multiply a common denominator. This has a 1 plus cos, but it's missing a 1 minus cos. So I times the top by 1 minus cos, and I times the bottom by 1 minus cos. That's how I got this first fraction. For the second fraction, same thinking. This is 1 minus cos. I want to have it 1 minus cos and 1 plus cos, so I times top and bottom by 1 plus cos. Now I have common denominator, 1 plus cos, 1 minus cos for both. I can make one big fraction, 1 plus cos, 1 minus cos on the bottom, and on the top I just add their numerators. So it's 1 minus cosine plus 1 plus cosine. Well, that turned out to be great, because you see I get 1 plus 1 is 2, and minus cos plus cos, they cancel out. Well, I get 2 on the top here. And that was good because I knew I wanted 2 on the top. But on the bottom I want sine squared, so I went back and looked at this denominator and decided to rainbow or expand this out using FOIL. So I did 1 times 1 and got 1, and 1 times negative cos gave me negative cos, and cos times 1 gave me positive cos, and cos times cos, there's a negative here, so cos times negative cos was negative cosine squared. Well, that turns out to be great as well, because I get 1 minus a cos plus a cos, these cancel, and you just get 1 minus cosine squared. And that's perfect, because 1 minus cosine squared is sine squared. Now I have that left side equals right side, and since left side equals right side, I've proven it true.